Hey everybody, so I wanted to make a video note just to go over some key concepts. So you copy down the notes, but if you want to hear me explain some of the concepts, then I would watch this video. So we're in this unit which is now similar figures. We've been dealing with congruent figures for the last several units, and we know now that congruent lengths, congruent shapes, congruent angles, they all mean that they're the same. Congruent means exact same. Now similar is a little bit different. Now I'm dealing with figures that have the same shape, but there's different sizes. So there can be an enlargement, it can be blown up, or there could be a reduction, it could be shrunk. And the key criteria, and that's what's boxed to the right there, the key criteria for similar figures is that you have congruent angles, so all the angles need to be the same, and the sides now are in proportion to one another. So if you think back to Algebra 1, when you were working on proportions, a proportion is showing that a ratio or multiple ratios are all equal to each other. For example, 1/2 is equal to, say, 3/6. Because 3/6 simplifies to 1/2. So those ratios, which can be represented as a division problem or as a fraction, those ratios all have to be equal. And that ratio is called the linear scale factor. And so basically when you compare all the lengths of the similar figures and you simplify them all, that simplified ratio is called the linear scale factor. Okay, I will draw your attention here. That symbol right there means similar. So it's like the sign that's on top of congruency, but remember how congruence has that symbol and then an equal sign underneath it. Well, these figures aren't equal anymore. They're similar. So that's the symbol for similar. And the similarity statement works just like congruency statements did because it matches up all the corresponding parts. It shows you how the congruent angles match up, and then it also tells you which sides are going to be proportional to each other. So there's the key thing to take away from this lesson. It's the criteria for similar figures: congruent angles, proportional sides. All right, so in example 1, we just listed the pairs of congruent angles, and then in number 2, we checked the ratios of the corresponding sides. And we wanted to state the linear scale factor from triangle ABC to triangle DEF. And when it's in that order, when I start at ABC and I'm going to DEF, when I'm listing my ratios, all of my segments from ABC, from that triangle, are going to be on top. Okay? So from this linear scale factor from triangle ABC to triangle DEF, ABC is going to be on top. The segments from DEF are going to be in the denominator. So when I checked all those ratios, they all simplify to 2/3. So the linear scale factor from triangle ABC to triangle DEF is 2/3. Because triangle ABC is shrunk. It's a reduction, and it's 2/3 of the size of triangle DEF. That's what that linear scale factor is saying. Okay, so in the bottom right-hand corner, let's say I flipped it around. I said, what's the linear scale factor of triangle DEF to triangle ABC? Well, then I just flip my linear scale factor because the DEF segments are going to be on top. So that's going to be 3/2. And that's showing that triangle DEF is 3/2 the size of triangle ABC. So it's an enlargement. It's getting bigger. Okay, so that's going to wrap up that first slide. This next one is just saying that the perimeters of similar figures follow that same idea. And so we worked that out in example 2. Okay, we found the linear scale factor. And then if we want to find missing values in similar figures, when we were dealing with congruent figures, it was a lot of setting things equal to each other. In similar figures, it's going to be setting up a proportion. So, remember setting up proportions from Algebra 1. I know you've done that before. So, if I want to find the value of x, I want to take the ratio that I know, and I figured out a ratio in 1a. I found that the ratio from this figure FGHJK to ABCDE, I figured out that the ratio between them was 3:2. So if I keep that ratio as is, that's what this first one is. That's the ratio I know. Now I need to set up a ratio involving x. And so x right here belongs to figure ABCDE. So it needs to be on the bottom. Because if you remember, when you set up a proportion, the numerators have to have the same criteria. So in this case, my numerators are going to belong to FGHJK. And the denominators have to have the same criteria. So they both belong to ABCDE. And then each ratio is corresponding parts. So with the x being a part of ABCDE, it has to be on the bottom. Its corresponding part over in the bigger figure, if I look at my similarity statement, x, which is AE, matches up with FK, which is 18. So that's why 18 is on the top there. And then to solve a proportion, we cross multiply. So I take 3 times x, I drop my equal sign, and I take 2 times 18. So that's how we got x to be 12. All right, very similarly, that's how we solve for the perimeter. And then in number 2 down there, the lengths of the sides of the triangle have a ratio of 2 to 5 to 7. Okay, so I set up a proportion. I found the perimeter of this ratio triangle because I knew the 3 sides of that ratio triangle. And I know that the length of the biggest side in the ratio triangle is 7. Okay, so when I set up this proportion, I have the length of the biggest side over the perimeter. So I've got 7 over 14. And this ratio right here belongs to my ratio triangle, which I made over here. Okay, and then over here, the blue represents the actual triangle. Oops, gotta spell it right. The actual triangle. So I don't know the length of the biggest side. That's what I'm trying to find. So that's what I'm calling x. But I do know that the perimeter is 84. So make sure when you're setting up these proportions that you've got those matching parts, that the numerators have the same category, the denominators have the same category. That way you're cross multiplying correctly. Okay? And then there were just some you try now questions. Make sure you are understanding these. Try it out. Start working on the homework. You got a quadratic here. Make sure you remember all that stuff about quadratics. Other than that, that's going to wrap up this video. Just make sure you copy down all these notes. Monday we will have time to go over these again as a class and for you to ask your questions on this and the homework. So that's it for 5-1. Make sure you've taken all those notes, start working on the worksheets, and also complete the 5-2 notes.